Hello, welcome back to my videos. Today I will talk about stack and queue in Java. The first part, I will introduce stack and stack methods. Then I will talk about queue and queue methods in Java. Firstly, built-in stack. What is stack? The stack is a linear data structure that is used to store collections of objects. It is based on last in, first out, as you can see here. Java Collection Framework provides many interfaces and classes to store the collection of objects, and Stack is one of them. Stack class provides different operations, such as push, in order to add an element to the stack. We have pop to pop an element. The size method returns the size of the stack. Pick to retrieve the first element. Its empty method is to check whether the stack is empty or not, and search is to determine whether an object exists in a stack. We can see the structures diagram of stack class here. Java collection frameworks provide a stack class that models and implements stack data structures. Stack classes in Java is a legacy class and inherits from vectors in Java. Here you can see on the screen, we have a diagram here. And the stack class can also be referred as a subclass of the vector, which means it can inherit all the methods from the vector class. We have an example code here. I create an empty stack and I pushed many elements 10, 15, 30, 20, and 5 into the stack. I do some methods or operations with my stack, and I got this output, as you can see. So the next part is queue in Java. What is queue? Queue interface is a subtype of collection interface. You can imagine in a real-world scenarios, queue insert element at the end of the queue and remove from the beginning of the queue. You can see. Java queue represent an ordered list of elements. Java queue follow first in, first out, or in a short, FIFO, order to insert and remove its elements. Java queue supports all the methods of collections interface. About queue implementations, since queue is an interface, if you remember, objects cannot be created of this type. We always need a class which extends this list in order to create an object. So most frequently, we used LinkedList. Or the second one, we can use PriorityQueue, which I will introduce these two later. About queue methods, we have a lot of methods here. We have add, pick, element, remove, pull, offer, and size. You can look through it, pause this video, and read through the description. In order to save time, I will skip this part. So come back to the implementation of queue interface. We have, firstly, PriorityQueue. PriorityQueue class, which is implemented in the collection of framework providers, a way to process the projects beyond the priority. It is known that a queue follows a first in, first out algorithm, but sometimes the elements of the queue are needed to be processed according to the priority. That is when the priority queue comes to play. The second one I want to introduce is LinkedList. LinkedList is a class which is implemented in the collection framework, which inherently implements the linked list data structures. It is linear data structures where the elements are not stored in the contiguous locations, and every element is separate object. Each element is known as a node with pointers and addresses. Due to the dynamicity and the ease of insertion and deletions, linked lists are preferred to use over the arrays or queues. And finally, I want to introduce you the concept of Enqueue and Dequeue. What is Enqueue? It is to check if the queue is full or not. If the queue is full, it prints overflow error and exits the program. On the contrary, it will increment the tail and add the element for us. About Dequeue, it is check if the queue is empty or not. If the queue is empty, it print out underflow error and then exits the program. Otherwise, if the queue is not empty, Dequeue then print element at the head and increment the head. So that is the end of my presentations. Thank you very much for watching.